Multi-factor authentication is widely considered the gold standard for securing online identity. We type in our passwords, approve a prompt on our phones, and trust that this layered defense will keep our data safe. Yet right now, secure corporate networks and cloud environments around the world are being breached, and the attackers are walking right in without ever triggering a single multi-factor authentication prompt. These adversaries aren't guessing passwords, they aren't intercepting SMS codes, and they aren't flooding phones with fake approval requests until someone makes a mistake. Instead, they are targeting a quiet, highly vulnerable byproduct of the login process. They are stealing session cookies. Multi-factor authentication is a heavily guarded checkpoint at the front door, but if a thief steals the specific file that confirms you already cleared that checkpoint, the gate remains open. By design, the architecture of the internet is stateless. When you click a link or load a new page, the web server has no inherent memory of your identity from the previous request. To maintain a connection, the server issues a temporary identifier after you pass your MFA challenge. This session cookie is stored in your web browser. The server doesn't verify the human, it only checks if the browser presents the correct data. If an attacker extracts that data from your browser and loads it into theirs, they inherit your exact level of access. They can read emails, manipulate administrative consoles, and download proprietary files without ever being asked for a password. The standard memory mechanism of the web cannot distinguish between a legitimate account owner and a thief holding the same session data. Attackers extract these session cookies using 3 distinct methods. The first is adversary-in-the-middle phishing. Hackers set up a reverse proxy between you and the real login page. You enter credentials and approve the MFA prompt. But because your connection passes through the attacker's node, they duplicate the cookie in real time as the server sends it back. The second extraction method relies on Infostealer malware. These are lightweight programs operating directly on a victim's computer. Once executed, they silently locate the local database files where your browser stores active tokens, copy them, and exfiltrate the data to a remote server. The third method happens inside the browser itself, using malicious extensions. These add-ons request permission to view website data, which allows them to scrape session cookies directly from active memory. This avoids the need to drop files onto the operating system or trigger network alerts. Whether intercepted in transit or pulled from a hard drive, a stolen cookie creates a silent ghost session. Because the session is already verified, traditional endpoint security and fraud monitors frequently fail to flag the intrusion. To combat this vulnerability, a new standard has emerged called Device-Bound Session Credentials, or DBSC. DBSC changes the physics of the attack. Instead of issuing a standalone file, the browser works with the server to cryptographically lock the session to a physical security chip inside your computer, like the Trusted Platform module. If malware moves that bound cookie to a hacker's remote device, the request is rejected. The remote machine cannot provide the cryptographic proof required by the microchip, and the server terminates the session. Shifting the anchor of trust from a software file to a physical hardware component invalidates remote cookie replay attacks, but attackers are already adapting. They have discovered that native browser debugging tools can be manipulated to bypass hardware encryption and dump unencrypted session data straight from memory. In 2025 alone, Infostealers harvested over 90 billion browser cookies. Relying on a single authentication event at the perimeter is no longer sufficient when those tokens can be captured post-login. Modern networks are shifting toward continuous access evaluation. Instead of checking a user once, systems must analyze behavior, location shifts, and device signals throughout the entire life of the session. Maintaining identity security requires verifying every action a user takes once they are inside the network, rather than simply monitoring how they entered.